Okay, in the third and last part of this lab, we will construct the circuits in figure 4. It's a second order RC filter. We are going one step forward and we're going to use two identical RC stages that are connected in cascade. Now after you are doing your calculations, we are going to connect the circuit. Now we're going to use the RC values and the pulse parameters that are identical for the figure, for the one with the ones that we used for figure 1. Right, and then we're going to observe the voltage across the second capacitor. Now let's do it. Now the components, R and C components that we used for figure 1 were 10 kilo ohm and 0.01 microfarad. So let's keep using them. Again, let's unplug our channel. Now instead of 0.02, we go back to 0.1. And we will, so this is one RC stage. We're going to put an identical RC stage as well. So let's do this. We have our second resistor and we need another 0.01 microfarad capacitor. Right. Let's plug it in series. Okay, now let's connect the lower ends of the capacitors and put the ground there. Okay, now our circuit is complete. We have our square wave power supply, we have our ground, and two RC stages. Now let's plug in our channel to, let's plug in our channel to measure the voltage across the second capacitor. Again, we are going back to waveforms, still using the same waveform, the square wave, and run. All right. Now let's stop. As we can see, the capacitor charges up pretty quickly and then discharges. Now, it charges up until 5.1, but it doesn't charge up as fast as the previous, the capacitors in the previous circuit. So that should be one thing for you to note. Let's keep running. And create our data and export. Okay. Another thing for you to note would be that there are two different time constants for these two capacitors because the equivalent resistance that they're seeing is different. And all right, first you need to write the loop equations and solve the differential equation. We already did the experimental procedure. You need to also construct a PSpice model, and in that simulation you need to create a step up using vPulse. Let me introduce that as well. That's something new. We didn't introduce that in the previous weeks. So you go to place, PSpice component, source, voltage sources. Now in the first week, in the introduction video, we used AC and DC voltages. This time you're going to use pulse. And that's the component. Now it has a bunch of parameters and I just want to introduce what they are. Now V1 and V2 are the lower and the higher voltage. Let's go to this figure. Now V1 in our pulse should be 0 and V2 should be 5, right? The low voltage and the high voltage. So V1 is equal to 0 and V2 is equal to 5. All right, TD and TR. TD is the time delay, like after how many seconds or milliseconds the function starts. You can set it to 0, no delay. We just want our waveform to start at time 0, right? TR is the rising edge, the time of the rise. I don't think you can set it to 0, but you can just set it to 1 nano. And the time fall should be the same thing, just 1 nano. Just very, very small values that are very close to 0. PW is the duration of the peak. So remember, our period was 0.2 milliseconds. So this should be 0.1 millisecond, and PER, the period, should be 0.2 milliseconds. So PW is 0.1 M, and the period PER is 0.2 M. All right, after setting the parameters to these values, you can connect this circuit by picking R and C components as I introduced in the first week, and just connect the circuit. Don't forget to put the scopes, and then run the simulation as described here. And you may also want to watch the introductory video from week 1 about PSpice, and just run the simulation and get the results.